Nintendo Switch. Let me show you what's going on. I'm a little concerned because I know the shop put power to this port. Now on this side you can see the pins are a little bit lifted. This side is what has me concerned. See if I can get that in focus for you. If you look to the far right, there are two pins basically broken off. I'm hoping it wasn't catastrophic. There's two pins touching on this side. You can see that. So, and they put power to it. So I'm a little concerned about the fate of this one. We will have to disassemble entirely, pull the port, and do some testing from there. Okay, we have the board out of the housing and we're ready to remove the port, but I already see some big areas of concern. So let's take a look real quick. I just got done cleaning this off a bit, and that is what happens when you plug power to a bad port. It's probably bonded to that trace. That's assuming it didn't kill the CPU, which is a big assumption at this point. So what we have to do now is we have to remove the port. We have to remove this Pi 3 USB. There's no point in even testing with the Pi 3 USB on there. Let's take a look at our M92236 and circuitry. Okay, well, at least there isn't a hole in it, but yeah, I'm not overly optimistic, but we'll remove the port and remove the Pi 3 USB, and then we'll do our testing. That's just how this is going to have to go. Okay, so let's get this started. While I'm setting up my equipment, we'll throw up our expected temperatures for this job. I'm not sure how long this job is actually going to last. We'll find out. If it didn't blow the CPU, it's going to be an interesting repair because I will probably have to do pad repair on that Pi 3, but again, not overly optimistic about that. It's pretty rare when you see something blow this way that it survives. But it does happen. We'll start with the port. Stubborn. The reason why I'm removing the port is because there are pins touching in the port, and that will also interfere with our testing. about as clean as pull as we can get it with this port. Let's make sure we have no bridges on the other side. Looks okay. Let's grab this pie. Do have pad damage there, but it's not quite as bad as I was anticipating. Still going to have to run a jumper. I'm probably going to have to remove that nub. All that's academic if it's still blown. So let me connect my meter. Alright, so we do not want a short here. And we do not have one. Hey, okay, there's some hope. Let's check around our M92T36. As always, we're checking the lines from the capacitors to the chip. There is one capacitor with two lines. One side will always be ground. Alright, this is the CPU chip. I mean the CPU capacitor. And it looks good. I don't know. I'm not getting... I don't think I'm getting a solid connection here. Okay. Alright, let me retest everything around that, because I don't know that I was getting a good connection on that CPU shield. Okay. Check our test pads. Well, first check our low filter. Okay. Check our invincible fuse. Still being invincible. Check our test pads. None of these should have a pathway to ground. Okay. Check our filter. Make sure we don't have a short on that filter. No shorts on those test pads. On the other side. Okay. Okay, I cleaned up around here, and now we're going to take a closer look at this blown pad. It left quite a little bit of a crater there. See if we can get this nub up, because it's not going to be of any use to us. I'm just going to break it off carefully. We don't want to rip up more of the trace. There we go. Let's grab our grinding pin. A pretty long runway here to run a jumper, or route it. Of course, we could possibly use a lug here. I don't mind using the lugs for one trace jobs. It's the 11 trace jobs that doesn't make sense for me. I love that grinder. Let's investigate the lugs here. That's about right. Okay. Now the trick for me on the lugs is you pretty much have to think about them in the opposite way that you would do a jumper. So with a jumper, you'll run it, you'll solder it down, you'll route it, and then you'll secure it down. with a lug, I find that securing it down first and then soldering it and routing it is the better way to go. The brand new Ineasies came in just in time. I got these specifically just for jumpers. I will not be using them generally for anything else. I tried the longer silver ones and they just don't have what the blacks do for me. Just want to check and make sure it's going to be the right size. That's going to be good, sure. Let's push that aside. Let's grab some conformal, or sorry, UV solder mask, and we're going to put it in this cavity here. Thin layer. That should do. Now we're going to deal with the lug. Get it in place. I'm not worried about getting solder mask all over it at this point. We'll scrape off what we need to. Just want to get it in place. Okay, looks pretty good to me. Okay, so we're going to grab our UV laser and we're going to use it. Sorry you were out of focus for some of that. And I do have my UV glasses on, but I am going to change scenes so you're not getting the blast of the UV in your eyeballs. I don't think it'll hurt you through the screen, but you know, people with epilepsy or something like that might be affected. I'm going to do assistive heat on this too, just a quick blast. To help with the curing. You may not be able to get the UV under there, but the heat will definitely get under there. Alright, feel pretty good about that. Switch it back. Alright, that feels pretty solid. Grab my X-Acto and scrape it off a little bit. We don't want really any on the pad itself. Or on the other pads. Okay, so I didn't do myself any favor here when I didn't tin the trace before putting down the lug. Okay, I think that'll work. Now we'll reroute this down carefully. We don't want to create fatigue here. All right, get a little better look at it. Let's check our continuity from that trace to the filter. Very good. Yeah, the lugs have so much potential for being a very elegant repair. It's just the expense. My issue with them is I have 7 rolls of different sizes of jumper wire or magnet wire, and those will literally last me beyond my lifetime. I mean, my nephew will probably be, using them when he's an old man. Compared to these lugs that are, anywhere from $6 to $13 a sheet, and might get you through. I mean, the iPhone ones will get you through quite a few repairs, but the the larger ones that would work best on consoles, you'd be lucky to get through one USB-C torn trace job on those. So they make sense for certain applications like this, but they don't make sense for everything. And that, of course, is just my opinion. Okay, I'm probably going to mix in some leaded solder on this. I wouldn't typically, but there's going to be leaded solder on that one pad, so we might as well lower the temperature of the other stuff too. Why I don't normally rework this area as far as like putting new solder on. It's just such a tight space. You could very easily get yourself in trouble. Off here. Okay, let's put our new chip on and hope it's good. I've had a couple bad ones in this batch. Remove your heat, let it dry a little bit, press down, bring back the heat, and then remove. Hold it down until it dries. Now we do some cleanup. Let's have a quick gander, particularly on our new pad. Can't tell if there's a gap there. I'm going to add a little solder to that. That was kind of a deep cavity that we put it in, so I feel a little better about that. Okay, that looks pretty good to me. We'll see how it works. I do believe it's making contact though. Okay, it's now more or less normal routine for cleaning up the port area. I'm going to add some leaded solder to these pads because I didn't add any low melt or anything to them this time. Alright, let's tin this guy up. Alright, let's tin up our port. And we are frozen. Okay, let's get these anchor points. Looks pretty good. Pretty good feed through. Let's check our pins, make sure they're all solid. Looks good. Now we clean. I'll come back when I'm done cleaning and ready to perform a test. So I never show the cleaning on screen, but I am using this to do the final cleanup on, or the more thorough cleanup on the port and stuff before I I'm willing to perform a test. I want to make sure the flux and stuff is out of the port, and this thing has been working great. This was an idea of Q's Tech Services, and I wanted to show it in a video so that he knows that I'm actually using it. So there you go, Q's. Okay, we're back and we're ready to start performing a test with the PSU. Let's see what happens. Okay, that looked pretty normal. Other side. That looked pretty normal. That's encouraging. Okay, now we'll try the battery dongle. Or battery squid. For this we'll use the OEM charger to activate. Looking on the far right hand side of the screen for this one. And we'll activate. And what we want to see here is a steady climb in current. And that looks pretty good to me. Very good. Not the end all be all, as always. We got to get it in there. We got to perform our tests. With it being such severe damage on the Pi, we definitely got to make sure we're docking. So we will reassemble enough to do some testing and go from there. Okay, we're ready to test with a charged battery. So watch the meter on the far left of your screen. 0.47, full battery symbol. Now fast charging, that's good. And we're booted up. And that's good. Let's check the other side. And fast charging on the other side. So excellent. Alright, we'll reassemble enough to do a dock test, but we'll probably have to let it charge on its own battery for a while. So I'll probably take a break, have a snack, and let it charge, and then we'll come back when we're ready to do a dock test. I started doing the dock test first because it really doesn't matter if everything else is working, if the dock isn't working, because I'm going to have to take it apart and deal with that. Okay, and this is pretty excellent. As you can see, it is docking. So our trace repair on the Pi 3 USB worked, our pad repair with the lug. So that's excellent. Okay, and as you can see, they're recognizing and charging both Joy-Cons. And Bluetooth is working. Just to make sure it's picking up our networks. And it is. Very good. Okay, and I'm not going to test the game because I don't want to put anything on their system. Usually, sometimes if they have it in airplane mode, they're trying to preserve something, so I don't want to mess with that. Okay, we're back, and as you can see, we have the board back out of the housing. I left this thing on charge for probably upwards around 4 or 5 hours, and it only got to about 63%. So that tells me that we still have an issue. I believe our issue is going to be the M92 T36. This revision does not have diode arrays or anything else that could be secondary causes of that symptom. So I believe we also have a failing PMIC. This one just keeps getting more expensive, but it's how it goes sometimes. So we're going to replace this chip. There's no need to taste. I mean, there's not really any point in testing because it's not failed in a way that's detectable through the meter, as far as I know. It's still kind of functioning. It's still communicating with the charger. It's just not fast charging on an OEM charger. So, all right, let's get our equipment set up and flux applied, and we'll just do a quick swap. Let's get this chip off. Quick hot swap back in. Make sure the solder grabs it before you let it go. Centered. Let it dry a little bit. Press down. We're checking for alignment and make sure it's flat to the board. It's pretty good. Also checking for micro bridges or anything of that nature. Looks pretty good. All right, I'm going to clean up off screen. Let's perform our test real quick. First, using our dongle on the PSU. Just want to see, make sure it still has normal behavior or expected behavior. Okay, that looked pretty normal. Always want to check both sides. Good. All right. With the batteries good, we have to activate with the OEM charger, so doesn't take long. We do have to have the channel on though. Doesn't take long. Just a quick in and out, and we just want to see current climb per usual. and that looks pretty steady, so I'm convinced it's working. Just want to make sure we're not going backwards before we go put it back in the housing. Alright, and that's the next step. We need to put it back in the housing. In this case, we're just going to let it charge, and hopefully it will fully charge the battery, and I'll come back and update and let you know the results. Okay, so we still got a little bit of strange behavior. I have it on the PSU at the moment. We're getting 0.93 through the PSU, but we're still drawing really low amperage, and the battery's only showing 57%, so I would be expecting to be drawing more than that. So still have an issue of some sort. I don't know if it's an issue with my trace repair on the Pi 3 USB. Okay, while I couldn't get this thing to really show fast charging on the meter, and I had the meter attached, it did fast charge. I put it on the OEM charger, and it charged right up from 67% up to 100% and almost, you know, like roughly an hour. So that's pretty normal. I'm going to hope this one's solved, but there's a potential that this one will come back, and if it does, I'll either do a part 2 or amendment to this video. But I believe it's working now, so here's hoping. Cross your fingers. If you haven't, so in summary, we had a torqued up port with some bent up pins, a couple of pins touching, and a couple of missing pins. Somebody stuck power to it after dorking up the port. It could have been the customer, the client, or it could have been the shop. That blew Pi 3 USB all to hell. Blew a pad off the board. Typically in those cases, when you see that type of damage, it's ripped for the APU, but in this case I got very lucky, so we were able to repair the pad on the Pi 3 USB and put a new Pi 3 USB on there. It seemed to be solved, but once I put it on the charger, of course we put on another port, you know, standard fare there. But once I put on the port, we had other issues. I thought we were finished and I wrapped it up, but I set it on the charger, and boy, for I want to set it on the charger like 6 p.m. and I came back at 11 and looked at it and was only up to 67%. So that was a problem. So I determined that the M92 T36 was probably faulty as well. We replaced the M92 T36, and right now I'm just kind of hopeful that it's solved the problem. It seems to be functioning normally now, but we'll see. I may have to make a part 2 on this one. Anyway, if you have any questions about the equipment I use in this video, take a look in the description below. They're all Amazon linked down there. So if you click on any of those links and buy anything during that session, it doesn't even have to be one of those tools. A small portion of that purchase will go to supporting the channel. Greatly appreciated. There's also some other links in the description if you want to take advantage of those. And memberships are now live, so if you want to hit the membership link and support the channel, you know, with a I have one, you know, as always with this channel, I'm pretty straightforward on everything. I have one tier. You can sign up for that tier or not. Anyway, if you like the video, do me a favor, hit the like button. And if you want to see more videos like it, hit the subscribe button and notification bell, and you'll know when I post new videos. And that's all I have to ask of you. Appreciate you watching. I'll see you next time.